Welcome to a new test and teardown video. This time it's a Philips PM5712 pulse generator. 1 Hz to 50 megahertz. And with a rise time of only 4 nanoseconds. Wow, I look forward to test that. This is actually going to be quite interesting because I also released a video about a 5711. So I believe that was the first pulse generator they made, and that one was from 1970s. I will put a link in the description to the 5711 as well, so you can see that. And this one is from about 1980. I look so much forward to see if we can find any ICs with date codes. So we probably can date this a little bit more accurately. But it's definitely a lot newer in design and all that kind of stuff. We got a lot more cool and useful features. Repeat time, delay, duration. I actually don't understand why we have a delay, right? So it's because when this is obviously the repeat time, but then there's probably a delay after the start, and then you get your pulse, right? Or you can have double pulses. So that means it starts the pulse and then a delay and then a new pulse. I don't know exactly about that. So we've got an auxiliary output, pulse output. That is definitely going to be the fast one. And we're going for 50 ohm output. And everything here is also variables. So that is great. I don't know about that dot. Maybe somebody pulled up the knobs because they are like not centered to the little dot here. Single shot, yeah, okay. Inverted auxiliary. So we can trigger, okay, zip external trigger, and then it will do the pulse. Ooh, I already found one problem. Ah, here we go. We need a little bit of cleaning and lubrication here. Maybe there's light in that switch. It looks like that, right? But this we definitely need to fix. So there's a good reason to open this. I made it work. Maybe I shouldn't touch it now. Maybe we can try and test it before we open it, huh? Let's look at the rear panel. It's really looking nice and modern. Nice IEC standard power connector, and it's easy to see if it is configured for 220 or 120 or 110 volts. And here is the model number 5712-07. So they obviously released different versions of this. 70 watts. Are you kidding me? Okay, so this explains this huge heatsink. Let's power it up and see if there's any smoke or kaboom. So I connected a scope and I left the switch in because it's a little dodgy. So let's just turn on the... Hey, we got pulses and a power consumption of 30 watts. I do miss a little bit of light here. There's no indications whatsoever what is going on. But yeah, look at that. We got some pulses. It looks really weird what is going on here. What the heck is going on here? Well, I'll have to DC offset. Okay, so this is the... Look at that. It's going in absolutely bonkers mode here. Okay, that is the problem. Oh, look at the jitter. Are you kidding me? So we got... Is this... What? Oh, look at that. We got light. Okay, so this is the repeat time variable. Oh, that jitter is just... Okay, so that is the delay. And then we move. Okay, I don't want delay. So that looks like it's working. I don't have delay right now, but there's definitely... Okay, so this is the pulse width. That switch, oh, okay. It's already getting better just by massaging this switch a little bit. So now it's the repeat time that is full of noisy. Let's do a little bit of switch massage. Nah. Oh, is it that? I need to clean a lot of stuff, but this looks like a ripple power supply kind of thing, right? Oh, yes it is. Look at that. Voltage is completely unstable. When you see this, when you're in 50 milliseconds, yes, this is mains frequency. Okay, power supply issues. I have to open and fix this thing. And I am inside. We got those little springy contacts from the chassis. And inside the top and the bottom, we got some metal like that. So we're still able to get a lot of air in and out, and then it's still nice and good shielded. This looks very modern, from a 1980 something kind of product. Oh, that is really nice. This back piece here is aluminium casted in one piece, and the transformer is mounted all the way back, and all that is looking really good. That is definitely a power supply, rectifier, bridges, capacitors and stuff. I really would like to measure a little bit around here what is going on with my scope. Look at that. All the pot meters, they're using a flat cable. So they're soldering the flat cable directly to the rear of all the pot meters and then into a connector here. This avoids all this cabling and wiring around. This is just time consuming, and you can solder stuff wrong. See all those cables and stuff like that. This is how equipment was definitely some years before this. So that is really a nice design. Let's look at the other side. Very modern of its age. Oh, I like that. I love it when you see voltages, DC voltage here. Oh, this is where you adjust the voltage. This is lovely. Thank you, Philips. And here we got... Oh, that is the output board. Output transistors, probably. Or DC offset, and that will be the faster output transistors, because that is slow stuff. So this will be fast stuff. We're talking about 4 nanosecond rise time. So we need to see some... Ooh, here we see some nasty stuff. Some fast transistors, yes indeed. Inside a heatsink biased real hard so they can run fast. That is how it's done. Definitely, this is the pulse amplifier, yay. Ooh. What is that? So in 1983, something was changed because of jitter. And now the jitter is gone, they say. Jitter is back, my friends. That is for sure. I need to figure out exactly what is going on here. Ay. That is all the different pulses and timings and funny stuff. Oh, look at that capacitor. 336.3. That's probably a tantalum or some bad stuff. Mains switch was a little bit dodgy, and with the light, and I really like that it's isolated somehow. This looks a little bit homebrew, But that means if you are poking around in here with mains applied, you could potentially touch something here and get an electric shock. So, I mean, just something is better than nothing. Also here you could touch, but then this is not so easy. You're not that stupid, are you, to touch this? Nah, you never know. Beautiful power supply, super easy to figure out what's going on here. Yeah, that is definitely what I'm gonna do first. Play a little bit with the power supply. I think I was right about my age assumption. If we look at the IC date codes, so that is from 80, 80, 81. So that was amazingly close. Oh, I am just lucky sometimes. Oh, this is the 6-volt supply. Look at that scope. I mean, I got 2 volts per division here, so there's a lot of ripple. So this is obviously, that was the first point I measured, and it is that bad. Okay, I kind of think we got it. All right. So here's a little trick when you're poking around with power supplies and ripple. Obviously, it's most often capacitors, they're like losing their value and getting higher and higher internal resistance, so they can't deliver the current. Here is the rectifier bridge. They mention on the little sticker note here on the side that was replaced, and then ripple was gone. But what they did is they mounted a little shitty bridge that can't handle the heat here. So this is the positive output. So I'm using this to measure with my diode checker here. So if I measure the 2 sides of the AC, remember, or you can see here I disconnected the AC wires from the transformer. So let's measure one side. Yes, there is a diode. The other side of the AC, oops, there's not a diode in here. And if I do it on the other side, yeah, I got my 2 diodes to the negative side. So there's a diode missing inside this bridge. And of course you're going to have ripple if the capacitor is also a little bit on the low side. There's a, I think it's this capacitor down here that is doing that. So yeah, we have to replace the bridge again. And then, why do you see a huge heat sink and the burning hot rectifiers there here? Why the heck aren't they down here on the metal here with some wires or something? This could have been solved if they used their brains a little bit. Yeah, but that heatsink is only for the series regulators. Yeah, okay, they get hot, but how about the bridges? I mean, also got some hot transistors here, and they are, of course, handled correctly. You need to distribute heat correctly and transfer heat, so you have like a design that is optimized for good thermal. I don't know. So that's the bridge they mentioned here. You see, DR302. That is the one that was defect. And then they put in such a tiny little shitty one, you know. I could, of course, just put in exactly the same little shitty ones, or put in something real big. This just don't fit. But I came up with an idea I think is actually a little bit better. I put a bridge right here and then I screw it to the metal like that. Yeah, okay, it's not ideal of the heat transfer and all that kind of stuff, but this is still like a million times better compared to just have it hanging in the air like that here. It's, I mean, there's actually a little bit mechanical transfer of heat here and stuff like that. So I think this is going to be okay. Now add some wires, and oh yeah, one thing, look at that. This is something you always need to double check. AC plus minus. But if you look at the most common way to do it, you see the pinout is different. So this is not going to work this tight. If you put this in here, you're going to break everything. So now the new rectifier is in here, and let's measure the 6 volt. Ooh, that is nice and clean. I got 2 volts per division. So remember, this is the 6 volt line, okay? Now we'll take the signal on the capacitor, and look at that. So that was the 6 volt output. There's like only 2 volts of margin, and it's not a super low volt, low dropout kind of design. So, I mean, there's not a lot of margin here. So, and also look the way this is jumping. The windings in the transformer is not symmetric or something like that, right? Why would it jump like that? That is not how it should be. And let's try and measure. Oh, my hand is in the way here. I'm sorry. Let's try and... okay, so it's 4 volts peak in ripple. Now I'll try and change the capacitor and see if that's any better. I changed the capacitor to a brand new, and I got exactly the same ripple. That's funny. So that was definitely not the capacitor. But what I did is I put in now 2 in parallel, and now I got almost half the ripple. It didn't really help a lot with the margin down to my 6 volts. I got like 2 point something. I got 4 point something volts, right? So, I mean, it's probably how it's just supposed to be. So, well, now let's try and test the pulses. So now I've been playing around with this unit for about an hour actually. And it is getting a lot better with the temperatures. Remember, my rectifier is right here. And look at that, it's only, what, 60? So that is alright. And the other one down here is 50 something. So yeah, that was definitely the hot rectifier, and that is the reason for having all those problems. But let's play a little bit with the pulses. I'm doing a 1 microsecond pulse, and I'm zooming in. I dialed down the output level because I wanted to measure the rise time of 4 nanoseconds. And look at that. Here's the rise time, 3.8 nanoseconds. So I got 2 nanoseconds per division. So this is the output. So that is really nice and fast. Obviously, if I up the amplitude, let me show you guys this. It was 3.8, right? And then I dial up the amplitude. Obviously, rise time is going to be a little bit slower. Let's see if we can do it like that, see? Then it's 4.8 nanoseconds. So depending on what you need. So let me zoom out a little bit for you here. So that is my pulse. Oh, this is my 1 microsecond pulse. Okay, maybe I didn't adjust it that accurate. It was supposed to be like here. There's a little bit of noise in the pots, and but other than that, I mean, see, this is the pulse and this is the delay. Obviously, you need to adjust the delay in the correct amount. Otherwise, this pot is going to be crazy sensitive. What happened here? You see? See, like that. It's just going absolutely crazy. But if I have it like that, then you can see it is quite alright. I can do that. Single shot works. Double also work. What did I do? I thought yes, look at that. Double. See, there's now a double pulse. Ooh, it's and double is really crazy sensitive to noise in this pot. And single shot also works. all you have to do is put that dial down to external. So yeah, I think I'm done playing with this unit. I just need to clean the on-off switch here and see if I can figure out why this bulb is not turning on all the time. And oh yeah, you see here as well, a little bit of noise in all the pots. DC offset also works. Alright, thank you for watching. See you tomorrow. Bye bye.